12.5, Law of Cosines. Essential question, can I use the law of cosines to find angles and sides of an ordinary triangle? Let's take a look at the proof for the law of cosines. And here's what we're trying to prove right here. Let's start with an ordinary triangle, and let's draw an altitude from vertex to the opposite side. This opposite side is called B, and this altitude is going to divide it into two pieces. We'll call one piece x, and the other piece will be b minus x. And we do have two right triangles because of this altitude. And this is one of the triangles right here. One of the right triangles. And because it's a right triangle, I'm going to be able to use the Pythagorean theorem. I'm going to be able to use this side, and this side. And I'm going to write out the Pythagorean theorem. This is the hypotenuse. Now I'm going to take a look at this expression right here, and I'm going to expand it. And I'm going to write it twice, and I'm going to use FOIL to help me expand. And this will be the expansion right here. So now I'm going to substitute. I'm going to go a squared equals b squared minus 2bx plus x squared plus h squared. So now I've made it look a little bit more complicated. I'm going to now go to the other side, which is the other right triangle, and I'm going to use the sides here, x, h, and c, and I'm using the Pythagorean theorem again. And what I've noticed is x squared plus h, x squared plus h. So I'm going to actually substitute, take this out, and put c squared in it. So this is going to be a squared equals b squared minus 2bx, and now I'm going to write plus c squared. All right, now I'm going to use the cosine of a, and here's the cosine of a right here. And the cosine of a is the adjacent over the hypotenuse, so that's why I have x over c. And then I'm going to cross multiply to figure out what that is. And now I have a substitution for x. So I'm going to have a squared, I'm going to have b squared, I'm going to write this second squared, minus 2b, but instead of x, I'm going to write what x is, c cosine of a. And so there is our proof. All right, let's take a look at the cosines and see if we can find a pattern that'll help us memorize this better. Well, it kind of looks like the Pythagorean theorem with something subtracted at the very end. Notice that if you start with side A, you end with angle A. Notice that this looks like the Pythagorean theorem minus 2, and then we still use these two sides in the product with the product of the cosine of A. Let's take a look at B. Okay, so here's angle B, and here's side B. And notice that if you start with side B, you end up with angle B here. And again, it looks like the Pythagorean theorem, minus 2, and then you take the product of these two sides times the cosine of B. And the same thing happens for the other relationship. All right, I keep saying that this looks like the Pythagorean theorem. So let's make B a right angle, and let's try to figure out what the cosine of 90 degrees will be. So let's go to our calculator, and the cosine of 90 degrees is 0. So what we're saying here is when you have a right angle, so if this ends up being a right angle, the cosine of 90, all of this becomes 0. Well, if this becomes 0, this whole thing is going to disappear, and you're just going to end up with these terms here. And isn't this the Pythagorean theorem? So we say that the Pythagorean theorem is a special case of the law of cosines. Let's take a look at solving for sides and angles using the law of cosines. Notice that this is a side, angle, side situation. Let's go ahead and write everything that we know right now. We know that angle B is 34 degrees. We want to find B, but we know that A is 11, and we know that C is 14. Okay, and so I'm going to identify the angle and the side opposite. So here's the B squared, and I know the side, and the angle opposite is angle B. So I know that's how I start my formula. Think about the Pythagorean theorem, and then minus 2, and then use these same two letters, A, C, and there you go. That's the law that we want to use. So this is going to be B squared is equal to, and our A is 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of 34. Now, to get b by itself, we're going to take the square root, and then we're going to take the square root of this side. And B is approximately, when you put it in your calculator, it'll be approximately 7.9. You ought to check that and make sure that you can get the 7.9. Now, to get one of the angles, we now have enough information to use the law of sines. So I'm going to say the law of sine of 34 degrees, and now I know what B is. It's 7.9. And then the sine, and I can find whatever angle I want. I think I'll start with angle A all over 11. And then we're just going to use the same techniques that we had before on the previous lesson. And then to get A by itself, I'm going to have to use sine inverse. And when I put that in the calculator, I'm not going to make you wait, but the answer ends up being 51.1 degrees. So 51.1 degrees. Now at this point, all we have to do is subtract from 180, and we're going to get 94.9. And this is what we call solving the triangle. Okay, here's another side angle side situation, but I've kind of got a head start here. We're looking for A, but we know that B is 23, and we know that C is 26, and we know A is 114. So I'm going to use the angle A, and the side A. Angle A, side A, and the angle A. And you notice that I put the rest of the numbers here. Makes it look like the Pythagorean theorem minus 2 times those same angles. And then we're going to take the square root of both sides. And when I get the square root of both sides, A is approximately this number. So this side is 41.1. Okay, and then just like we did before, we can use that angle, sine of 114, with the side, and then just find whatever angle we want, sine of B over B, and then we're going to get B, which is 30.7 degrees. And then after you figure that out, you can subtract from 180 to figure out what C is. Let's go on to the SSS case. In this case, we don't have any angles, all we have is sides. So little a is 12, little b is 27, and little c is 20. Okay, so it doesn't matter which angles I work with. I'll just pick 27, which is a little b and angle b, and I'll use that. So remember, I'm going to start with b squared equals, and then I'm going to end with cosine of b. You just use the Pythagorean theorem, a squared plus c squared minus 2 times ac. So here's the formula that we're trying to use. So this is going to be 27 squared equals 12 squared plus 20 squared minus 2 times 12 times 20, and we're looking for the cosine, and this is what we're looking for. We're looking for b. Before I can get this by itself, I've got to get rid of this addition that's happening. So I'm going to do 27 squared. I'm going to subtract 12 squared minus 20 squared. So I've subtracted all the addition here, and now I have this product right here. Now to get b by itself, you really have to isolate cosine b first. And that means I'm going to have to divide. So in my numerator will be 27 squared minus 12 squared minus 20 squared minus 2 times 12 times 20. Now to get b by itself, I've got to do cosine inverse. And then we'll have the 27 squared minus 12 squared minus 20 squared all over negative 2 times 12 times 20. Now when you put it in your calculator, you've got to make sure the calculator has a parentheses around the numerator and a parentheses around the denominator. And if you do that, and you ought to really check your work to make sure you can do that, you will get 112.7 degrees. So angle B will be 112.7 degrees. Now to figure out the other angle, you're going to go to sine. So now that we know angle B, it's 112.7 degrees all over 27. And then we can find angle A, sine of A, all over side A, which is 12. And I'm going to assume that you can solve that. And when you do that, A will be approximately 24.2 degrees. So A is 24.2 degrees, and I'm going to assume you can get the rest. Okay, this is the last problem. It's kind of a half-done problem. I have all the sides here, and so I've decided I was just going to try to figure out angle A. So notice that I have angle A here, and I have side A right here. And notice that I took everything to one side. I went ahead and divided, and then I took the cosine inverse, making sure to put parentheses around the numerator and denominator, and I got this answer. Once I get this answer, I can find angle C and isolate sine of C, and then isolate C by putting all of this inside the parentheses. And so our A was 58.1 degrees. C is 36.2 degrees, and I'm going to assume you can figure out angle B. Okay, your turn. All I want to see is if you can identify the case for each one of these triangles. Can you identify whether it's side angle side or side side side? And here's the answer.